Yeah, I've been recording for like
Okay, so for the past week or so, we have been looking at volumes of revolution, right? Like our little party hat over here. If I were to, we'd call it a volume of revolution, because if I take my lightsaber and I slice it going across the hat, if you can imagine what that looks like. Slice it across the hat, and you look at the slice. What's the slice?
Solid.
A half sombrero, okay? Sadness, it's that time. Okay, maybe the sphere will be better. I take the sphere and I slice it, and I say, hey, look at the slice. What are you going to see?
Circle.
Wow, okay, we're there. What you would see is a circle. I mean, we take the sombrero, I slice it, wow, going right across, and I show you, hey, here's like the bottom half, and I turn it so you can see where the lightsaber went by.
Oh.
We're okay?
Yeah.
All right. We would slice it, circle.
Yes.
Now, what about over here with the wedding bell? If I slice it like this way?
Circle.
Circle. Now, if I slice it this way, weirdness happens, right? Mm-hmm. We've done volumes of revolution with a particular slice. Now, the poor pineapple has had its better days. But imagine I'm slicing so that we're going just the right way. What are we going to get?
Circle.
Circles. We're constantly getting circles when it's a solid object. When it's a hollow object, you would get
A donut.
You would get a lifesaver, you would get a donut, you would get a big circle with a small circle taken out. Everything has been circles. Everything. Because that's what you get when you revolve. However, Adolfo, can you hold this up nice and high so people can see it, but be careful with it? So this little project, which is something that you guys are going to do after the AP exam, is not a volume of revolution. Does it have volume? Sure, it's three-dimensional. But it's not a volume of revolution because you wouldn't get something like this by spinning. What you do is you build it with squares. So, Ruby, can you hold this up? You're going to want two hands, though. You're going to want two hands. This is somebody's project. Okay. If I take my lightsaber and I'm going to slice, I promise Ruby I'm well trained. I'm a Jedi, okay? If I slice, and I say, hey, look at the slice, what are we going to see in this case?
Square.
A square. What if I slice it up here?
Square.
Down here?
Square.
In the middle?
Square.
Square. You're always going to get squares.
Well,
Somebody else hold the shape. You can put that one down. Okay. Rebecca's shape. Hold it. I promise I'm well trained. Okay. If I slice it this way, what are we going to get?
Rectangle.
Everybody's okay with rectangles? Somebody hold up another shape. Okay, Alex, hold it so everybody else can see it. Okay, so however you're holding it, I'm going to slice. And I slice, wow, right across. What are we going to get? Depending on how you're visualizing this, you might see it as a triangle, you might see it as a square. Unfortunately, it's not a finished piece. It's crown molding that would go up against the ceiling. There's another project out here somewhere.
It's right here.
Oh, it's over there. Alex, can you hold that one up? Okay. So take a gander at that solid. Maybe you want to turn it a little bit. Pretend you're Vanna White, right? You're like a model. Look at we're moving. We're slicing. Now here comes the slice. I'm going to slice. Here it comes. Whoom, all the way through. What are we going to get?
triangle.
Triangles. Your slices are different. We're good? Mm-hmm. All right. So here we go. Stephanie, what I want you to do is nothing. You're well trained at this. Okay. All right, so what I've got over here is my circle. What I need you to visualize is a three-dimensional object that this is the base. This is the bottom piece of this three-dimensional object. So normally the orientation is going to be things are coming out of the board at you. I wish I had 3D glasses. That would be fun. I'm going to go to the movies a lot this summer, so I'm going to just get all of them that I can, right? They say recycle, but I think it's a suggestion. Okay, so we get the three-dimensional objects. They're coming out. Now, what Geometer Sketchpad does, do you see the button where it says drop y-axis flat?
Yes.
Drop it. Stop. Okay. What happened is we have our x-axis. You have your y-axis, which is normally vertical. What's happening here, though, is we've rotated it so it kind of goes into the board. Just trying to get everybody oriented here. You have your x-axis. Your y-axis normally goes this way, but instead we're saying, no, lay it flat. What's this thing, then?
The axis or the shape?
The axis. So instead of x-axis and y-axis, you've kind of taken it from this to flat. And now we're going up. X-axis, y-axis. Julie, what's this going to be?
The z-axis.
Thank you for going for the obvious choice here. The x-axis, the y-axis. Welcome to 3D land. This is the z-axis. Not named accidentally. If you have an x and you have a y, I think the next one should be the z-axis. Last class, there was some argument that it should be the r-axis. Like, on what planet does that letter come next? Okay. So the thing that was flat on the screen is now kind of tilted into the back. What we're going to do is we're going to actually draw some three-dimensional objects. So what I want you to do is click Show Chords. So we're just running a chord from one side of the circle to the other. And Stephanie, hit C4 squares. I always like the sound effects. So the squares start on one side of the circle. They go across to the other side of the circle. However long this is, that's also... I'm getting ready to go to Boston. Okay, however long that is, that's also how tall it's going to be. We're good?
Squares.
Take out my lightsaber, I make my slices. What are we going to get?
Squares.
Squares. We pay attention to the cross sections. So try to visualize the three-dimensional version of this. All right, what I want you to do, my friend, is sweep one square. So what we're getting here is that one square. Hit sweep one square again to pause it. So the square slices start over here. They come across to this side. Right? We're looking at basically around the y-axis. Going from this side over to here, and then they come up out of the board on the z-axis. So we're going into 3 dimensions. But any place she stops it, hit it again, and then stop it whatever you want to. Any place she stops, it's still a square. Stop it over here, small square. Stop it in the middle along the diameter, big square. Stop it over here in the end, tiny square. Always squares. Hit create solid. This should help you get a better understanding of what's going on. Yeah, keep going, please. I think it kind of looks like a bird cage, maybe. Right? You've got like this wireframe model, but the base stays the same. It's a circle. Every single slice is a square. And what you're making is this 3-dimensional object. Questions so far? Joelle? Okay, hit show solid. There we go.
Well, do you take into account like what's below it?
No. So I'm going to define the base as the circle. Like this is the flat. We're not going to look below it. We're going to use that base and we're going to build up off of it. Okay? Other questions? Connor?
Why does it, in the, on the x-axis?
Yep.
At like 3, I think that is. Why does it V out?
Why does it V out? Oh, what? You're still like this part over here?
Yeah.
That's the edge. Any questions you guys ask are good questions. Like I think visualizing 3 dimensions on a 2-dimensional surface is hard. Yeah.
You want us to find the area of volume?
One more time?
You want us to find the area of volume?
I'm going to want you to find the volume since it's 3-dimensional. This is where we're going. We're going to talk about how do we find the volume of a 3-dimensional object when it's not a volume of revolution. Go ahead.
3 axes.
On 3 axes.
So 3D.
Other questions? Everybody okay? Andy, you good? All right. Miss Wynn, you good? All right. So show us the 4 squares again. The plus 4 squares. Right, just like further confirmation. Every single slice is a square. And the question earlier about why it V's out, if you look at where it's bold, that's like the vertice of your little squares. That's where it's touching. So that's like your edge. Okay? And now, why don't you click on one of the ones at the bottom? Because obviously not everything is going to be a square. There are other slices that are friendly. So why don't you click on circles with equilateral triangles? Okay? And let's go through the same process but quicker. Show chords. Drop the y-axis flat. Right, this is just to help get you a different perspective, Amanda. The slices this time are equilateral triangles.
Why are they squares?
Why aren't they squares? Just because I've decided I don't want squares all the time. I could pick any shape that you're familiar with, which is a limited set.
It's just not going like that.
Right, it's no longer a volume of revolution. You start with the base, you define what the slices are going to look like, and then we're going to pull out the calculus to actually get there. Okay, hit show solid. There you go. That's the wireframe model this time. And okay, we've got squares, equilateral triangles, any shape. Any shape is good. All right, so you're done. Thank you very much, Andy.